This video is our intro to equations and inequalities. And then I put as a subtitle here, key ideas for launching into what I call the fun stuff. I think there's a lot of fun to be had in algebra and in the concepts and what we can do and model with them. But the key to having fun is to have that launch pad set up. And that means having a really clear idea about things like order of operations and what are equations and what are we trying to do with equations in the first place. So let's start off with the definition of an equation. What is it? You've probably heard the word used. I've heard the word used incorrectly a lot, often by my own students. An equation sets two algebraic expressions to be of equal value. So off the top of my head here, I'm going to make up two algebraic expressions. So we might have 2 times x plus 3, and we might have, I don't know, 3x minus 4. And what an equation will do is it will set these two expressions and say they have the same value. Now, a great way to picture that is to picture it on a balance scale. Okay, so by that we mean one of these kinds of scales here, where the value of what is on the left side is equal to the value of what is on the right side, and so the scale is balanced. If you can keep that picture in your head of what an equation is, that will serve you well throughout your entire math journey from beginning to end. The symbol for an equation is really common, and I am sure that if you're watching this video, you've seen it before. It is that right there. It's the equal sign. It's two parallel horizontal lines. And sometimes when we're looking at that picture, people will actually put the equal sign into the little triangle there to indicate that we have equality between those two expressions. And that's going to set us up for our strategies for how we solve equations. We're going to develop a bank of things that we know we can do to equations, and it really hinges on the idea that the left side is equal to the right side. So I'm going to give you some examples of equations. We'll start with something that's so silly it seems mundane, but we'll start with like 4 equals 4. So that is a really simple algebraic expressions. We have a constant of 4 is equal to the constant of 4, and this is important because this is known as a true statement. And that's going to hinge into our definition of a solution. So 4 equals 4, 3 equals 3, 1/2 equals 1/2. Those are all examples of true statements, as opposed to something like 3 equals 4, which is known as a false statement. 3 does not equal 4. Okay, so important distinction there. Now let's see if we can come up with a more interesting example. 2 times x equals 6. Okay, that is an example of an equation. You've got the expression 2x on one side and the expression 6 on the other side, and we're saying that those two sides have equal value. We can make it interesting. We can do 4x minus 5 is equal to 7. So 4 times a number x, then minus 5 is equal to 7. And I want you to pause here and note how our math is already really building. So if we were to plug in a number here, we would need to use the substitution skills. We need to know how to evaluate the expression, so that vocabulary word, evaluate, and know our order of operations in order to be able to work with that. So we're not too many lessons into our algebra journey at this point, but we're already beginning to build that content. Here's another example. We have a plus 4 is equal to 2a minus 3. So a reminder that we can use variables other than x. X is the most common one that we use, but we could have a's and b's. So the next one here has an n in it. So you could actually have a squaring in there. So n squared is equal to 15 plus 2n. So notice some of the variation that we can have. We can have what's called a quadratic. Now you don't need to know that vocabulary word at this point, but it will come up again. So you can have like squaring going on in your equations. You can have the variable on one side of the equal sign, or you could have the variable on both sides of the equal sign. None of that is going to change our definition of an equation or our solution to an equation. So those are some examples of equations right there. So what is a solution? I am going to star this. I'm going to star it at the beginning and the end. If you were to ask any of my students that have had me for any length of time, what is a solution? We get about halfway through the school year and they can all pretty much spit back this definition. It is the value of the variable that makes the equation true. Now you'll notice that I pluralized that. So the values of the variables that make the equations true. That means that this definition will apply to much more complicated problems where you have more than one equation and perhaps more than one variable. So you might have an a and a b, or an x and a y, and it would also apply if there's actually more than one value of the variable that will make an equation true. So this is a really, really powerful definition. When you are asked to solve an equation, this is what you are being asked for. And I tell my students this applies at the very, very beginning of algebra, but it's going to go all the way through all of your algebra and beyond. When you are asked to solve something, solve an equation, that is what you're being asked for. And as your math journey goes on and you build more content, you're going to add tools and new different things that you can do to find those values, but it never ever changes what you're looking for. So we're going to look at one of those examples. We're going to look at a plus 4 equals 2a minus 3. And we haven't done any algebra at this point to figure out what the solution is. That is coming very, very soon. This is just a problem where you've been given 3 numbers and you're just asked, is this number a solution? Meaning, does this value for a make the equation true? So the way we go about answering that is we substitute in. So we have a plus 4 equals 2a minus 3. And we're going to take that value of a and plug it in. So everywhere we have an a, we're going to plug in a 3. And I want you to notice that this uses some of your prior math skills when it comes to substituting in. It involves your math skills when it comes to evaluating an expression, and it's going to use your order of operations skills. On the left-hand side, we have 3 plus 4 is 7. On the right-hand side, we have 2 times 3 is 6. And then we need to do one more line here. 6 minus 3 is 3. And we end up with 7 is equal to 3, which is a false statement. So the answer to the question there is no. A does not equal 3. Notice how I'm working from top to bottom. Okay, so each one of these is going top to bottom, not left to right. I have a quick little short I made the other day on why we structure everything top to bottom. Very, very practical reasons for doing so. Okay, so a equals 3 is not a solution. So let's try a is equal to 5. So we'll plug in a 5, 5 plus 4, and we want to know if that is equal to 2 times 5 minus 3. 5 plus 4 is 9. Notice that equal sign getting tracked down every single line. Okay, we don't have appearing or disappearing equal signs. 2 times 5 is 10. And we need one more step on that right-hand side. 10 minus 3 is 7, and we get 9 is equal to 7, and that is also a false statement. So 5 is not a solution either. Let's try a equals 7. So a plus 4 equals to a minus 3. We're going to plug in the 7. And this time we have 7 plus 4 is 11. 2 times 7 is 14. And one more step on that right-hand side, 14 minus 3 is 11. And this is what it looks like when you get a true statement And so our answer would be yes, A equals 7 is a solution. Now you might be thinking, like that looks like an awful lot of work. Do I really have to just like guess and check or have somebody else give me values? No, not at all. So we have better things coming, like as I said, more fun stuff coming. But for now, this is really about cementing in your head, what is a solution? How do you know if what you've done brings you to a solution or not? Now, here's a quick application, and this is where I think math gets really, really fun. You are at a carnival and have $24 to spend on games. It costs $3 to play a game of darts. How many games can you play? Write an equation that models this scenario. Now, notice it doesn't say solve an equation. It just says write an equation. Please always read the directions. So there's a couple different ways that you could do this particular one. There's not one way of expressing this, but one way you might express it is if it costs $3 for each game of darts, and we call G the number of games that you play, $3 times the number of games has to be equal to $24. Okay, where G is the number of games. And notice that I use G for games. So that would be one way you could write that equation. So 3G equals 24. Now, you might have done this. Well, if I have $24 to spend and it costs $3 per game, then the number of games would be 24 divided by 3. That would also work as an equation. So that meets the requirement of an equation. 24 divided by 3 equals G. And again, you don't have to solve it, but you might have gone in that direction with it, which puts you actually a step closer to the solution and might even give you a tip off for how we would go about solving this. So what about this equation here? All right, now to reason this out, I'm going to go to our definition where we have that balance with the equal sign. I'm actually going to draw a picture of this, and drawing a picture is a great strategy for you to use in tons of different problems. So if you're doing a problem for your teacher and you're getting stuck, like draw a picture. So we have two ends on the left side. So I'm actually going to draw that out as like two ends and then 5. So I'm just going to do like 5 little squares here. Okay. So that's on the left side of my equal sign. And on the right side, I also have 2 ends, but over here, I only have 3 of those little blocks. Now, as you're looking at the picture, okay, and remembering that this is supposed to be balanced, this should seem weird to you, that if you have the same thing in terms of the ends, so you have 2 ends on both sides, so the 2 ends should balance each other out. And then you've got 3 of the little blocks on the right, but over on the left, you've got 5 blocks. So you might like kind of think of it this way. The ends balance each other out, and 3 of those blocks are going to balance each other out. But you've got this problem where the left-hand side actually has 2 extra blocks. So this, in spite of the fact that you've got this equal sign, is actually going to do this if you were to like do this in real life. Okay, like a seesaw here or a teeter-totter, whatever you want to call it, because those 2 extra blocks are going to weight it down. Now, what this means is that this can't actually be equal. So you might think, that was dirty ball. You put the equal sign there. What this means in terms of the equation is that there is no solution. Okay, so there are no solutions to this equation. So you could plug in however many numbers you wanted to plug in, but you would never, ever get a true statement out. So as an illustration, suppose we just pick n is equal to 5. Okay, so we start plugging in 2 times 5 plus 5 equals 2 times 5 plus 3. So we have 2 times 5 is 10. and then we have the 10, and no matter what we plug in, we're going to have the same number in this position here, whether it's 2 times 5 is 10, or 2 times 3 is 6, or 2 times 4 is 8. And then on one side, we're going to be adding 5 to it, and on the other side, we're going to be adding 3, and that's never going to be equal. Okay, and that means that there are no solutions to this. So is that a little bit dirty ball? Kind of, sort of, but it's also something that might happen where somebody might just slap an equal sign between two things that can never be equal. In the practice set, you'll see another example. So let's talk briefly about inequalities. Now, for a more thorough refresher, see the video linked in the description. So I have a much more thorough refresher of inequalities to go into more detail about what the symbols are. There's actually one symbol, okay, and it looks like that, and that symbol can be turned around. Okay, it's the same symbol, but it might be turned around the other way. And that symbol represents one side of the expression, I guess, being of greater or less than value than the other. You might have heard the little alligator analogy where you've got whatever it's pointing to is the less, and then the alligator is hungry, and so it's always eating whatever is greater. Okay, and again, if you need a more thorough refresher on that, please click the video in the description box. So as a quick inequality example there, you might have like 2 is less than 3. So we would read that as 2 is less than 3. Or you could read it the other direction. If you read it the other direction, remember the alligator is always hungry. So you would say 3 is greater than 2 because of like the direction of the symbol when you hit it. So if you hit the pointy end first, it's a less than. If you hit the open end first, it's a greater than. So we don't normally read from right to left. If we were going to read that, we would probably just rewrite it like that. Okay, and we would say 3 is greater than 2. And then you might also see this where you have the equal sign underneath it. So this is like a marriage between the inequality symbol and the equal symbol, where we just kind of import the bottom part of the equal symbol into that. And that adds an or equal to our expression. So whatever we have, so we could say like it is or equal to. Now, if you only have numbers in there, that is not particularly meaningful, but it is meaningful when we're talking about an unknown, when we have a variable. So let's take a peek. Is P equal 4 a solution to? So here's our inequality. So remember that definition is a universal definition. This is going to work all the time. So we have 4 squared is less than 12 plus 4. 4 squared is 16. 12 plus 4 is 16. And we get 16 is less than 16. That is not true. Something can not be less than itself. So that is false. And we would say, no, that is not a solution to. But if we incorporate that equal sign, okay, so this is the same expression over here, and we end up with 16 is less than or equal to 16, now that becomes a true statement, and the answer is yes. Now, I could also have something that is bona fide less than, so we could do P equals 0 and get 0 is less than 0 squared is less than or equal to 12 plus 0. Okay, where we have 0 is less than or equal to 12, and that is also true. And that would also give us a yes. So sometimes students do get a little bit confused. If you have the equal to, it could be equal to, or it could satisfy the less than, either or. That's why we have the word or in there. So it's less than. If it's less than, yay, it's true. If it's equal, it's also true. It's less than or equal to. Now, as always, please like and subscribe if you found this video helpful. Comment if you have questions or want to see a video on something specific, and click out the link for the practice set on our introduction to equations and inequalities.